Hello everyone, this is Kudo Chien from pre-recording video. This is my first time to have a talk in such a public event and in such a form. When I speak to the camera and pretend that there are other people, I feel that being a YouTuber is really hard and programming is easier. My topic today is extending React Native to the next platform. This was the title when I submitted a React Native EU code for paper. At that time, I was not sure if I could finish my proof of concept in time. Well, as some of you may already know, the proof of concept was done. So, ladies and gentlemen, today I will show you extending React Native to a Flutter-like cross-platform architecture. Before that, please let me introduce myself. My name is Kudo Chien, and the Twitter account is Kudo Chien. I'm a React Native enthusiast from my limited of work time. I have some side projects like React Native VA, which is a VA JavaScript engine replacement for React Native. I really love React Native's architecture that we could extend the fantastic React.js declarative component-based UI development into other platforms. This saves me from the traditional mass-based or then MVC with fat controller mobile development. I would like to see if I could truly write React Native on every platform. My current full-time job is at Cloudmosa, a startup to do the Puffin browser, a cloud-based browser. And it is modified from Google Chrome open source project, Chien. So I got a little familiar with Chien stuff. That is the background that I could introduce this topic today. Okay, let's go back to our topic. Today we could already write React Native on some platforms. We have the officially supported iOS and Android, Microsoft open source layer out of 3 platforms for Windows and Mac OS. There are also React Native DOM on web and React Native desktop on Qt, but they were not updated for a while. In my opinion, in the past days, to add an out-of-tree platform is difficult. From the bridge, native module manager, and to the UI manager operation queue, that requires pretty much work. However, React Native is an active project. To follow upstream changes is really terrible, especially for individual maintainers. Thankfully, the upcoming React Native architecture redesign, the core team had more cross-platform insight. The JSI, Turbo module, codegen, and most importantly, Fabric. As you may heard from the past months, with these new stuff today to extend React Native to a new platform, I do believe things will be easier. The best way to learn and clarify the details is to have a hands-on experience. I learned JSI from React Native V8, and in this project, I learned some details about Fabric. I will show my understanding to you later. 3 years ago, Google open sourced their cross-platform solution, Flutter. People often compare React Native with Flutter, and I always be curious about the reason people to choose Flutter. Some people choose Flutter because they don't like JavaScript. Well, I don't have comment for that. Some people choose Flutter because they think Flutter has better performance. And I was thinking that with the Beauty architecture from React Native, it is possible to port React Native into a Flutter-like solution. People said that Flutter is fast because they don't have native views and directly use GPU to draw UI graphics. In fact, Flutter uses Skia as its foundational drawing library. What I'm going to do is using Skia to draw React Native views. There are some goals of my proof of concept. First one, it will be as minimal as possible, simply to support views, images, and tags. There will be no interaction and no animation. Second, the code should be cross-platform and avoid to write platform-dependent code. In the proof of concept, I will demonstrate in Mac OS, but in theory, the outcome could be extended to other platforms easily. The third one, avoid to patch React Native's code, hopefully to be a true out-of-tree platform. Let's start our journey. We will write an out-of-tree platform from scratch. Because React Native code is written by C++, On the way, you may need some C++ background. First, I'm going to introduce Chien. Chien is a cross-platform 2D graphics library. It supports various GPU backends such as OpenGL, Mantle, and Vulkan. Besides Flutter, Chien is also be used in Google Chrome and Android. Chien focused at graphics drawing, so it don't have concept about view hierarchy or how a native window is being hosted. I mean, for NS window in macOS or UI window in iOS. However, to integrate Chien into React Native, I need those stuff. Thankfully, in Chien example code, there are some simple implementations. They are SK app. I will borrow SK app into my proof of concept. Next, it's the building tool. Facebook internally uses Bug to build React Native. Chien uses Chien and Ninja. Both Bug and Chien are cross-platform component-based building systems. We should choose one. At the beginning, I tried to use Chien because I am familiar with Chien, and it is really hard for me to port Chien builder into Bug. Chien's building script is really complicated. On the other hand, a critical problem is that React Native Fabric heavily relies on a Bug-specific feature. The header namespace and its portive prefix. That makes me hard to use Chien for Fabric. At last, I turn to use Bug for the whole system. And for Chien, there is a trick. I used Chien and Ninja to generate pre-built libraries and use Bug's pre-built CSS library feature to integrate. After building React Native and Chien successfully, we could start to write code. The diagram is the first version of the architecture. The blue part, React Chien app, is the main program. It is actually the Chien Hello World code to draw some simple graphics, and it has some underlying SK app window and SK app layers. On the other hand, on the right-hand side, there is an instance which is to host most important React Native module, the Facebook React instance. To initialize React Native instance, 4 components are necessary. Instance callback, which is to receive some events. We could use the default empty implementation. Module registry is responsible for legacy native module, and we could leave it empty as well. We should implement the remaining 2 components, JS executor factory, about the JS JavaScript VM, message queue thread, about message loop. Message queue thread is responsible for message loop, or in the name test queue or test runner. You could see there are 3 pure virtual functions to implement. I had some choices before. The first one, to write a handy C++ simple message loop from scratch, or to port Chromium's message loop or message pump here. And the third one is to looking for some other C++ cross-platform solution. At last, I chose Foley, simply because we already have Foley and I also want to learn more about Foley. The Foley event bus is a good fit for our requirements, and there is a problem that event bus is not yet supported to build in React Native OSS. Let's add the support, and then I added 2 box targets, Foley async and Foley synchronization. Because they rely on other third-party libraries, libevent and OpenSSL, I also used the same strategy before: download, pre-build, and add box pre-built CSS library. There is a final implementation, just to call 2 functions: run in event-based thread and run in event-based thread and wait. It's really simple. The other React Native instance component is JS executor factory. It is the factory to create JavaScript VM, which is named JS executor here. As far as I know, in the past days, this was difficult as we should implement a bridge here. From the newer React Native, JSI Executor is a cross-platform and unified solution toward JS Executor. Since we are on macOS, we could reuse existing JSC runtime and integrate with JavaScript code. After React Native instance is initialized, we could then execute the JavaScript bundle. And then I use the load script from string function. If there are any JavaScript errors, there will be C++ exceptions. I'd catch the exception and write to log. The JS bundle is very simple. It has some views, actually just two views, two nested views and with different color. The button is the CLI command to generate the bundle. After executing the JavaScript bundle, we should see some JS errors. In the example, the error said the platform constants module is missing. Okay, it's time to Turbo module. Let's have some brief introduction for Turbo module and JSI. I think Eli from React Native Code team will mention more details in his talk. From my understanding, JSI, the JavaScript interface, which is an abstract of common JavaScript operations. The underlying implementation relies on JavaScript engine's C++ interoperability. You could use JSI to create JavaScript scalars such as number, boolean, string, or object. Moreover, JSI hosted function is that you can declare a function in C++ and export it into JavaScript world. When you call the JavaScript function, the implementation is actually in C++. JSI hosted objects concept is similar, but it's for JavaScript object. Turbo module is based on JSI to support native module system that you may be familiar before. Native module, you could have tons of methods, and some of them could even return promises. Let's see how we scratch a Turbo module. Take platform constant module as an example. How many properties we need to implement? The first one is to reference from JavaScript spec, the JS file, and see the flow type. The other one is to reference pre-generated native spec, and it is really hard to read. Sometimes writing JSI code is really troublesome. And that is in fact React Native CodeGen did. CodeGen will save us from writing troublesome JSI code. It will use flow node to reference JS flow typing and generate corresponding native code. This ensures type safety and doing JSI correctly. React Native's Turbo module system also did a lot for cross-language interoperability. For example, wrapping Objective-C or Java to JSI C++. For our system, since we are all in C++, we could write Turbo module by JSI directly and not to use CodeGen. This is a code snippet of platform constant Turbo module implementation. For the final Turbo module manager, we have these modules. Some of them are unimplemented empty modules, simply to make JavaScript happy to find this module. Some of them need further constants or methods, but most methods are also no OP. Time module is a special one. It is an underlying implementation of JavaScript set timeout or set interval. For this, I could also use fully event-based supported function, schedule at. The last one, UI Manager module, is a legacy workaround to make JavaScript UI Manager happy. The actual UI Manager will be Fabric. Even more, in the future React Native's bridgeless mode, it seems UI Manager module is not necessary. Finally, there are no more JS errors. When executing the JavaScript bundle, it's time to add Fabric and integrate with Skia. Well, in my opinion, Fabric is more complicated than previous part. The most critical module of Fabric is the scheduler. To initialize Fabric scheduler, two dependencies are worth to mention. The first one, scheduler toolbox, and its underlying event bit factory and component registry factory. The other one is the scheduler delegate and sometimes called the mounting manager, which is responsible for component operations such as creation or deletion. Since there are no interaction in my proof of concept, I only implemented the creation operation. Let's go for each part. The event bit factory is also related to matched loop implementation. From my understanding, they are UI thread matched loop and original shadow thread matched loop. This part is the only platform-dependent code from my proof of concept. The reason is that the platform UI thread matched loop is encapsulated in Skia's SK app. So the workaround is to use Apple Core Foundation's CF run loop get man to get a singleton UI matched loop. The actual code is copied from React Native with iOS. Component registry factory is the place to put all components registration. And the component descriptor is the class to describe the shape of the component, which could include name, unique ID, and shadow node related stuff. For each component, we should register with a concrete component descriptor. Taking view as an example, its component descriptor will be view component descriptor, and you could find this in React Native source code. And CodeGen will also generate component descriptor from external component. Fabric's component only covers shadow stuffs. A shadow node or shadow view is like a virtual shape of a platform view. It is smelling like a virtual DOM. Well, to integrate with true platform views such as UI view in iOS, we need an extra place to associate shadow view with platform view. In my proof of concept, I also put the associations in the component registry factory. In React Native Skia, we had some RSK prefixed component stubs, and the RSK component provider will create corresponding RSK component. RSK component have an instance, and RSK component have an interface unpenned that support to add Skia drawing command into Skia's SK canvas. As a slide shown, we will call drawRect for React Native's view, drawBitmapRect for image, and drawSimpleText for text. After we initialize the component registry, we could go further with the mounting manager. We could get a shadow view mutation here. The mutation is to describe if there are new view to be created or view to be deleted. As mentioned earlier, I just implement the create mutation in my proof of concept. In a mutation, we will get a shadow view. There are some critical properties in shadow view. Let's have some more examples. Component name or component handle could be used to get or create a component by previous component registry. Props and state have some meaningful information. For view, we could get such as background color here. And the layout matrix is about view spawn or position after calculated from Yoga engine and from your styles. So we don't need to integrate with Yoga here. They are covered in Fabric. There is an example to show how to get the information from shadow view and draw by Skia. That is from my RSK component view unpenned function. The first step is to get the background color from the casted shadow view props. Then created the SK pen from the color. Shadow view's layout matrix is where we could get the frame position and frame bounds, and we could create a SK rect from the frame information. And that's just to draw the rect with a SK pen. Then I started to integrate previous SK app window into Fabric that introduced the RSK surface window. it will be attached to Fabric and Mounting Manager. RSK component could then interact with it. For the proof of concept, I have support for some simple view, image, and text. As a code snippet shown, there is a background view, an image to show React logo, and a text that React Native loves Skia. And then there is the final result. For me, it was an exciting time. I really scratched the platform from ground up. The final component diagram is like that. There was an instance to host a Facebook React instance and JSI Turbo Module Manager. At the right-hand side are Fabric-related stuff, the scheduler, component view registry, underlying RSK components, and Mounting Manager. RSK components are previous SK app layers. RSK service window is previous RSK service window is previous SK app window. And now they are integrated together with an instance. It's near to the end of my talk. People may likely to ask how about to launch React Native Skia into real world. My answer is that we still need a lot of work. As you know, I did not implement most of Turbo modules such as networking and WebSocket. I did not implement all Fabric's shadow view mutation, so views should not be updated after some props changed. More importantly, there are still some other missing critical steps such as input event, heat testing, and animation. And that is from React Native's point of view. On the other hand, for Skia, as mentioned earlier, Skia does not have view hierarchy concept. We should add a true layer system instead from SK app example code. The layer compositor will be a critical part. Some optimization like you could ignore Skia command outside of your viewport. In Flutter, there is a module called Flow to handle the layer composition. And Flow is pretty much like Chromium's CC compositor. They are both critical and complicated systems. Even we are still far from production code, I will open source my proof of concept code after the conference. Hope if there are someone who interested in this project and we could do it together. In the final of the talk, I want to leave this question. After adopting Skia, will React Native could be as fast as Flutter? The answer may be yes and maybe no. How do you think about Android native Vue's performance? How do you feel about the performance of Android Web View or Electron? Both they use Skia to draw graphics. So the most important thing is how we implement the system, and it may not simply related to Skia. Always profile and see how much we could improve before coming out a conclusion. Thank you, and hopefully to see if the dream to write React Native everywhere comes true one day.